In this video, we're going to talk about types of chromatography, specifically exam-style questions on gas chromatography. So this is the video where you do the questions and then allow me to explain. So you have to interpret gas chromatographs in your exams. So it's really, really important that you can understand the different ways in which you can do that. It is quite simple in terms of what you need to do. Just concentrate on the interpretation. Now, let's remember that the peak area is relative to the amount of compound present. It's not an absolute, it's not an amount, it's just a relative number. Okay, so we've got our peak coming up here, and we've got a peak at about 5 minutes and one at just below 15. Let's do the areas, and you've got 4.9 and 5.9 for A and for B. In this question, and often, they will give you some further information. So the further information for the alcohol, which is A and B, is that the MZ of a mass spectrum is 74 and 102. Well, that means that is the molecular mass. So we've got the molecular mass of A and B. Now let's look at the question. So the question itself is the concentration of alcohol A in the cosmetic product is 1.11 times 10 to the minus 2 grams per decimeter cubed. Now that's of A, which has a peak area of 4.9 if you look over there. Now it says calculate the concentration in moles per decimeter cubed. So you've got to convert grams to moles, okay? And you've also got to take the amount of A and convert it into the amount of B. Let's put this down to the bottom and highlight the key areas. So we've got to give a concentration in moles per decimeter, change it from grams per decimeter, and we've got to go from A to B. So if we then look, first of all, we've got to do the conversion. So we've got to convert, okay, and we've got to convert grams per decimeter to moles per decimeter cubed. So basically the only difference between there and there, okay, is going to be between the grams and the moles. So basically we've got to convert grams to moles. Okay, to convert grams to moles, okay, you use the equation mole equals mass over molecular mass. Okay, so all we then do is take what is our mass, because you know there's 1.11 times 10 to the minus 2 grams, essentially, because we're just converting the grams to the moles. Okay, and we got that from down here. And we're going to divide that by the molecular mass of our first one, which is going to be A. Okay, so this is our number of moles of A. And A up there, you can see, is 74. Okay, so if that is the case, let's write that out. And we find that that is 1.5 times 10 to the minus 4. Okay, so we've basically converted that into moles. Now, if that is the case, we can then say, well, because there's 1.5 times 10 to the minus 4 moles of A, that means that we can just add the moles per decimeter on the end. So basically, we're just converting the G to the mole. Okay, we never change the decimeter, so we can just add that on the end. So basically, the concentration of A is 1.5 times 10 to the minus 4 moles per decimeter cubed. Now we need to do the conversion to B. So if you think about it, there's a ratio here. So basically 5.9 and 4.9. So if we take our 1.5 times 10 to the minus 4, okay, and we times it by, okay, 5.9 divided by 4.9. So we've got a ratio there happening, okay, and that will take it from the amount of A to the amount of B, okay, which will equal our final answer. So our final answer equals 1.81 times 10 to the minus 4, okay, and that is in moles per decimeter cubed. And that is how you use a gas chromatogram to take the relative peak area of 1, okay, as in A, change the converting units to moles per decimeter cubed, and then use that to give you the concentration and the concentration here of D.